Hello students, today's topic is critical radius of insulation. Let us first understand why there is a need to define critical radius of insulation. I hope you have gone through the previous lectures of conduction and convection and you know how to write the conduction resistance and the convection resistance. Fine. Suppose there is a solid wall, right? And I want to put insulation on this wall. Before that, let us understand there is a medium, right? This medium is having a heat transfer coefficient of H and suppose some temperature T infinity. The medium temperature is generally denoted by T infinity. The solid is at a higher temperature and it is losing heat to the medium. Suppose you are adding insulation and this is the insulation thickness. What happens as you add more and more insulation on this solid block? Okay, so let us say that the insulation is having thermal conductivity of K and the thickness of the insulation is L. The area, the cross section area of course is A. Here it is everywhere A because it is a solid slab. Okay, so can you write the total resistance here? The total resistance should be the sum of conduction resistance plus the convection resistance. How to write conduction resistance? L by Ka. I hope you are aware of this, right? In the previous lectures, I wrote heat transfer is equal to the driving force by resistance. So, Q is equal to T1 minus T2 divided by L by Ka. L by Ka plus 1 by Ha. This A is the cross section area which is perpendicular to the direction of heat transfer. Suppose this is the direction of heat transfer. So, which area I am talking about? I am talking about this area, right? Now, just think that what should happen as I am adding more and more insulation means the thickness of this insulation keeps on increasing. What is going to happen as the thickness increases? L will keep on increasing. What about K? It is the property of a material, it is not going to change. A, cross section area, it is a solid block in the form of a rectangle slab, it is not going to change. H, it is the property of medium, it is not going to change. But as L increases, the total resistance also increases, and as the total resistance increases, Q must decrease, right? You keep on adding insulation, more and more insulation is added, the heat rate decreases. Fine. So, there is nothing special in this case, and that is why there is no need of defining critical radius in the case of a solid slab. Fine. But suppose instead of a solid slab, you have a cylinder. I also gave you the formula for calculating the resistance for a cylindrical body. Suppose this is a cylindrical wire or any other shape, any other case, but the shape is always cylindrical. Now, I am adding insulation over this. Of course, if it is a cylindrical body, the insulation will also be cylindrical. Fine. Suppose I am adding insulation. Right, this is the insulation. The insulation is also in the cylindrical form. Now, what should happen in this case? As you keep on increasing the insulation, fine, what is the total resistance here? The conduction resistance of the insulation and the convection resistance of the medium. Suppose again the medium is having heat transfer coefficient H and temperature T infinity. I hope you know how to write the conduction resistance. The conduction resistance is, suppose this is the point, the axis, and from this point to this is R1 and this is R2, but I am not writing R2, I am just writing R. Why? Because I will keep on increasing the thickness and therefore that R should change. So, I am just writing R, right. So, what is total resistance? If you remember, it is ln R by R1 divided by 2 pi K L. Here L denotes the length of this cylinder. This is the conduction resistance only. What is the convection resistance? The convection resistance is again 1 by HA. What is 1 by HA? 1 by HA must be 2 pi RL. This is how you write total resistance. So, the total resistance is the sum of conduction resistance plus the convection resistance. Now, think about what happens when the insulation is increasing. As the thickness of the insulation increases, R increases. Now, as R increases, this resistance, the conduction resistance is increasing because there is no A here, rest everything is constant, only R is variable. What happens here? The convection resistance decreases. Fine. So, as R increases, the conduction resistance increases, but the convection resistance decreases. This was not the case when there was a solid slab, because here the area remains constant, only the thickness of insulation was increasing. Therefore, one resistance was increasing while the other remained constant. Here, because as you are adding more and more insulation, the cylinder is becoming thicker and thicker and the area is increasing, right? So, with increase in area, the conduction resistance increases, but convection resistance decreases. So, what happens to the total resistance? If you make a plot, then as R increases, the total resistance passes through a minima. Means at some radius of insulation, the total resistance of this heat transfer is going to be minimum. So, what happens? The total resistance first decreases and then increases. This is the radius of insulation. At that radius where the total resistance of heat transfer becomes minimum is called critical radius of insulation. In the case of solid slab, we cannot define critical radius of insulation. Why? Because here the resistance is not changing its nature. It is just, you see, as L increases, the total resistance is just increasing, while here the resistance is first decreasing and then increasing. We know that the heat loss is inversely proportional to the total resistance, and therefore, if you make a plot of Q versus R, the heat first increases and then decreases. So, this is called critical radius of insulation, right? So, there are many questions in examination that what happens at the critical radius, the heat loss is maximum or minimum. So, it should be very clear that at the critical radius, the resistance is minimum, but the heat loss is maximum, right? So, how to find critical radius? Very simple, you differentiate this expression with respect to R, because I want to find R. Differentiate this expression with respect to R and equate it to 0. Now, the mathematics is very simple. When you do this differentiation and equate it to 0, you are going to find that the critical radius for a cylindrical body will be giving you, the value will be equal to K by H. So, if the radius of insulation is equal to K by H, the heat loss will be maximum. Fine. Now, it becomes very important to understand that what should be the actual insulation thickness, less than the critical radius or more than the critical radius. Now, very simple answer is it is dependent on the case, right? In some cases, we want to increase the heat loss. Like for example, in the cases of current carrying conductor. If conductor is carrying a current, we will never want that the conductor's temperature should go high, because it will be melting the conductor. So, we always want that most of the heat should be lost, should be dissipated into the surroundings, right? So, we want more heat loss there. But if suppose you are having a steam carrying pipe, in case of a pipe which is carrying steam, we want that the steam should retain its heat because it is going to be used elsewhere. Therefore, the heat loss must be minimum in that case. So, this is the case for a cylinder. Similarly, if we consider a spherical body, suppose you have a sphere and sphere is covered with an insulation. The radius of insulation is not fixed. We are increasing the insulation. Suppose this distance is R1 and the radius of insulation is R, right? Now, here what are the resistances? First, again the conduction resistance and the convection resistance. You will find that as you increase the thickness, the conduction resistance is going to increase, but the convection resistance will decrease, because here also as the thickness is increasing, the area available for convection is also increasing. So, the resistance 1 by HA is decreasing. So, here also we can define critical radius. So, what is the critical radius for a spherical body? If you do the derivation, you are going to find that the critical radius for a spherical body is 2K by H, right. So, it is very important to understand that there is no meaning of defining critical radius of insulation in case of a solid slab. while we can define critical radius of insulation for a cylindrical body or a spherical body, because when thickness of the insulation increases, the area at the exterior surface also increases. So one resistance will increase while other resistance will decrease, which will lead to some minima or maxima. So whenever there is minima maxima pattern, we can define critical radius of insulation, while here the resistance was only increasing, right? Because L was increasing. Here the resistance first decreases, then increases, right? So that's all about the concept of critical radius of insulation.